In this video, we will talk about indices and logarithms. Indices can also be expressed as exponents or powers. So if you have a number raised to an index or power, call the A the base and B the power, index, or exponent. There are a few laws governing exponents or indices. Now, if you have two numbers with the same base x raised to different powers and are being multiplied, all we just write is the base, then we add the powers. If they are dividing, we just subtract the powers. Now, if you have just one number raised to a power and everything is raised to another power, you multiply the powers only. And if you have two different numbers being multiplied together raised to a power, it's the same as the two separate numbers raised to the same power and multiplying each other. If you have two different numbers dividing and raised to a power, it is similar to the two different numbers dividing but all raised to the same power. If you have a number raised to a negative power, it is equal to 1 over the number raised to the positive power. If you have two numbers dividing raised to a negative power, it's the same as the reciprocal of the two numbers all raised to positive power. There are two special cases. Any number raised to the power 0 or index 0 is equal to 1. Any number raised to the power 1 is equal to the number itself. So these laws and rules will be applied to all the following questions making use of exponents or indexes. In these examples involving exponents, we have the first question: simplify 7x to the power 4 times 4x to the power 3 times half x to the power 2 divided by 3. So we'll apply the product law in this case because the bases are the same, but the powers are different. So we'll just isolate the coefficients of the variables and then multiply them together, whilst we also add the powers of the variable x. And we'll arrive at 14x to the power 23 over 3. In the second question, we have the base 2 raised to algebraic powers. Now, we will reverse the product law for exponents in the first step because 2 raised to the power n plus 4 is also 2 raised to the power n times 2 raised to the power 4. It's a reversal of the product law. So when we do that, this is what we get. And we'll do the same for the denominator. And then further, we will factorize the numerator, which means we have to extract out 2n times 2 outside the bracket. And we'll get 2 raised to the power 3 minus 6 in the bracket, inside the bracket. Now what happens afterwards? We'll further simplify and then we will get 8 minus 6 all over 2 raised to the power 2n times 2 raised to the power 2. Now we realize that the numerator gives us 2. Therefore, we have all our bases the same. Hence, we can go ahead and then apply the quotient law to this rational expression. And we'll get 2 raised to the power 1 minus, into brackets, 2n plus 2, which will give us minus 2n minus 1 as the power of 2.